You ever wonder how that package you ordered online shows up at your door so ridiculously fast? Or how an airline juggles thousands of flights a day without everything just falling apart? Well, the answer is this hidden science, a secret weapon born in the chaos of war that now, quietly, runs pretty much every part of our modern world. So let's pull back the curtain on this amazing field called operations research. Our story starts not in some fancy tech company, but in a war room. It's World War II. Allied bombers are taking devastating losses over enemy territory. Every plane that makes it back is a miracle, but way too many don't. They had a life or death puzzle on their hands, and they needed to solve it, like, yesterday.
So put yourself in the commander's shoes for a second. You can't just armor the whole plane, right? It'd be way too heavy to even get off the ground. You've got to be smart about it. You have to reinforce the most vulnerable spots. So, where do you put that precious armor?
The logical move, and what the military did at first, was to check out the planes that actually made it back. They mapped out every single bullet hole and saw a clear pattern. The damage was all over the wings, the main body, and the tail. The answer seemed simple, almost obvious. Slap the armor on those spots. But then, this statistician, Abraham Wald, he looks at the exact same data and sees something completely different. He realized everyone was being tricked by the evidence they could see and totally ignoring the evidence they couldn't.
Walt asked the one question that changed everything. The planes they were studying were the survivors. By definition, the damage they had was survivable. The real story, the most important data, wasn't on the runway. It was in the wreckage of the planes that never made it home.
And here's the brilliant insight. The fact that the returning planes were shot up on the wings just meant a plane could take a hit to the wing and still fly. This is a classic case of survivorship bias. The truly critical spots were the places where the surviving planes had no damage at all. So the totally counterintuitive but life-saving answer was clear. Put the armor where the bullet holes aren't, on the engines, on the cockpit, because a hit there was catastrophic. It meant the plane went down. That's why you never saw a plane come back with holes in those spots. This insight, it saved countless lives. This way of thinking, using math and logic to untangle these huge, messy problems, was the very beginning of a brand new field. They gave it a name, operations research. To put it simply, operations research, or just OR for short, is basically the science of making better decisions. It uses math and stats not just to find a good answer, but to find the optimal one, the absolute best possible result you can get with what you have. And it does this with a seriously powerful toolkit. R isn't just one thing. It's a mix of disciplines, like statistics to make sense of the data, optimization to find that perfect answer, and even game theory to figure out what your competitors might do next. At its heart, OR is all about finding the extremes. You're always trying to do one of two things: either maximize something good, like profit or efficiency, or minimize something bad, like cost, risk, or waste. It's about pushing things to their absolute best case limit. As you can imagine, a science that was this good at solving military problems wasn't going to stay a military secret for long. After the war, these techniques started to completely transform business and industry. And the bomber problem wasn't a one-off thing. OR analysts also took on the U-boat threat to Allied shipping. The question was, is it safer to send a bunch of small, fast convoys, or just a few big, slow ones? By crunching the numbers, they proved that what really mattered was the number of escort ships per convoy. The data was crystal clear. A few large, heavily defended convoys were way, way safer. But sometimes, the biggest breakthroughs came from the simplest ideas. In the hunt for those U-boats, OR analysts found a way to give Allied patrol planes a 20% edge before the enemy even saw them coming. And what was this game-changing tech? A can of paint. Seriously. They figured out that by painting the planes white instead of the usual black, they blended in with the cloudy sky. U-boat crews spotted them 20% later, which meant they had way less time to dive and escape. And getting 20% closer wasn't just a small improvement. It led to a massive increase in effectiveness, a full 30%. That's a 30% jump in subs attacked and sunk. It's just an incredible result. It didn't come from a new weapon or more airplanes, but from a simple coat of white paint, all guided by data. That, right there, is the essence of operations research, finding huge improvements in the most unexpected places. So this wartime secret didn't stay secret. After the war, the field just exploded. In 1947, the invention of something called the simplex algorithm
gave it the mathematical horsepower it needed. By the 50s, OR was being used everywhere. And today, with modern computers, it's the engine running our most complex systems across the globe. So, how did this military strategy tool jump from the battlefield to your web browser? Well, now it's so deeply woven into our lives, it's like an invisible operating system for the entire modern world. Just think about it. That insane, complex dance of scheduling thousands of planes, pilots, and crews to get them all to the right place at the right time. That's OR. The global supply chain that gets a gadget from a factory halfway around the world to your house in 2 days? Pure OR. It's the math behind managing financial risk, the optimization that keeps your cell phone calls from dropping, and even the dynamic pricing that figures out how much your Uber ride costs. Let's make it super simple. The second you click Buy Now, a whole chain of OR kicks into gear. It's already predicted that you might buy that item, so it's sitting in a warehouse near you. It's managed the inventory to make sure it's in stock, and then it solves a version of the famous traveling salesman problem on a massive scale to find the single most efficient route for that driver to get that package to your door. Its impact is just enormous, touching basically every corner of the economy. Transportation and manufacturing absolutely depend on it. Finance uses it to build safer investment portfolios. Service industries use it to schedule staff so you don't wait in line forever. Even governments use OR for everything from city planning to disaster response. It makes our whole society run better. And that's really the whole story, isn't it? There's a direct line from analyzing bullet holes on a bomber in WWI to optimizing the route for your pizza delivery. It's all part of the same quest, using data and math to find the absolute best way to do something, whether the stakes are winning a war or just getting dinner while it's still hot. So, the next time you book a flight, or get a package a day early, or even notice the traffic lights are perfectly timed, you'll know the secret. You'll see that invisible hand of operations research at work. Now that you know what to look for, the only question is, where else are you going to spot it?